So thank you so much for this opportunity. This is also the result of a VIP paper from Spain that Timo Hoek, Sergio Melgosa, and myself wrote, and is available at the Airbase at AIVC webpage. So all the details are there and can be seen there. And first, I'm going to talk about whole building airtightness, and then we will move to ductwork airtightness, and Sergio will explain everything about that. So first, we will begin with some context. We have to acknowledge that Spain is a country in which we have traditionally ventilated with natural ventilation through advantageous openings and with window airing by the users. So airtightness hasn't been really an awareness and hasn't been really a priority until very recently. So we are talking about the new regulations in 2019, in which for the first time whole building airtightness was limited, and for the first time there are requirements on whole building ventilation. We have to say that window permeability limits have been in force since 1975, but this wasn't really controlled or had any kind of importance, and the change has really came 3 years ago. And the reason is because in dwellings, there is mandatory mechanical or hybrid ventilation systems since 2006. So these advantageous openings and air infiltration is not really necessary anymore. And also because of energy performance reasons, this came into force 3 years ago in the technical building code, and specifically in the document which is about the limitation of the energy demand. So let's see what this document says, and let's begin with window airtightness. First, this is just a quick note. These are the limits of window permeability at a pressure difference of 100 pascals. And those are the limits depending on the climate zone. So for colder climates, the limit is more strict, and for example, the Canary Islands and Mediterranean areas, the limit is not as stringent. About the air envelope airtightness, well, please note that it's only for new buildings, new residential buildings, and for dwellings which are bigger than 120 square meters. So this is only for very specific kind of buildings. And instead of being based on the climate zone, this is based on compacity. So the ratio between the volume and the area of those dwellings, and those are the limits, as you can see on the screen, based on the N50 metric, the air changes rate per hour at a pressure difference of 50 pascals, and are between 3 and 6, depending, as I said, on the capacity. So this regulation tries to promote or to encourage compact buildings which are from the design with a good or good ratio about the volume and the envelope area. The thing is that there is no need to test to prove compliance. There are two options for this airtightness limit justification. We have option A, which is to perform a blower door test according to ISO 9972 and method 2, but there is no other specification or any further guidelines specific for Spain. And another important point is that there is no qualification scheme for testers, so there's no official training, no certification, not recognized or accredited agencies or companies to perform this kind of tests. And also there's no quality control. So this is like something that is not really under control. But the most widespread approach is option B, which is to calculate this N50 value analytically through this equation that is on the screen, which is basically according to the dimensions of the building, to the air permeability of the windows, and based on reference values which are there depending on if the building is new or existing with improved airtightness or existing. So this is what basically most practitioners do to calculate it. And this value is then used in the energy performance calculation. So it's mandatory for every new building. And we then compare the results obtained from this option B, this analytical approach, with real air tightness values. And we proved that there is a lack of linear association between the values of the technical building code model and the test values. So well, we think that this model should be improved. And by the way, this is the part of a paper that we published developing an envelope airtightness predictive model based on real airtightness values from a representative sample of buildings, of dwellings in Spain. So about the context regarding the tests performed, we have to say that there is no official data regarding either testing or tests performed. So there is just the feeling from, for example, Sergio's company and Timo's company that for the past 10 years, there has been an increase in testing, mainly promoted by voluntary certifications like Passive House and BREEAM LEED or something like those. And since 2019, with the new regulations, there has been a slight increase, but still the preferred option is to justify it analytically. About the airtightness database, so there's no national airtightness database. Companies have their own results, and those results are unavailable to the public. So we only have the data obtained and published in research papers derived from research projects since 2011. We had the opportunity to develop Infiles project, which was the first research project which has a representative sample of dwellings all around Spain, as you can see here in the figure. And this shed light to beginning on to having some data about how the building stock was behaving in terms of airtightness. So this is the evolution of the airtightness levels through the years. These, as I said, are results from this project, and we found that there is no statistical significant relationship between the airtightness and the period of construction. We could see just a slight trend of improvement over the years. And the reason we think is basically because this lack of concern about the impact of air infiltration, both on the energy and the ventilation performance, because we still have very spread traditional building systems which don't take into account airtightness, and workmanship is decisive in this issue. And because so far there has been no requirements, and even though there are now requirements, there is no mandatory testing. So we think those are basically the most important reasons. We have to say that there is no recent data. We don't have recent data concerning airtightness testing since the new regulations came into force. So this is something that we this data would be interesting to see how this is developing for the past couple of years. So to conclude, we have experimented some raised in the awareness for the past few years. We see these new regulations as a positive progress towards energy efficient buildings, but we still think that it's not enough. So we expect more demanding limits for the following years, and also mandatory compliance, and also not for restricted to dwellings, but also for any kind of buildings of any size, at least for the most extreme climate zones. And the gaps we identified are basically mandatory testing, because we think that if testing is not encouraged, we don't know how the built stock is behaving in real terms, or at least improving this analytical approach with more accurate results. We think that an airtightness database would shed some light on what's happening on new dwellings. And of course, a qualification frame for testers, we think it's key in order to have and to to comply with this kind of with regulations and with the standards, with testing standards, and also there should be some specific guidelines for the specific construction systems and building components in our building stock. So now, thank you. I will pass the ball to Sergio Melgosa, who will continue with ductwork testing. Thank you so much.
Let's keep going with duct testing in buildings. This presentation is made with my own experience in this kind of test. It's not a study of how is the market or the state of the test in Spain, because this kind of tests are also a little bit new, so it's more my own experience, like you can see in the picture. Yes, it is mandatory. This test, the duct test, is mandatory in Spain. We have our own regulation. The RITE, you can see in first point, is the HVAC regulation in buildings, and it says that all duct must be tested. Depending on the A, B, C, or D class, you have to test all square meters of the duct installed in the building. So there's no unspecific qualification for the company or the people that is going to do the test. Maybe who is doing this kind of test? Well, companies like me that do every kind of test in buildings, diagnostic in buildings. but also laboratories or the own installers of the ducts. They maybe some of them that are a little big companies, they have its own equipment. And what kind of installations are going to be tested? This is not a test for ducts in family houses, because that kind of ducts are really small, and there's no test in that kind of buildings. Family or multi-family houses is really strange to test the ducts, the outtakes or intakes ducts. Public schools or not, they are not testing. Maybe non-public schools a little bit of test. Office buildings, yes, they are testing because there are many buildings with some kind of certification like BREEAM, LEED, and they are asking for this kind of test. Hospitals also, they are testing, and well, the rest of the buildings, but most of them office buildings. As you see in the pictures, the test is not easy to do in the workplace. There in the picture you can see one of the equipments I used, the small one, and it's going through the workplace is hard to find the ducts, to test from one floor to another floor. These difficulties makes that the test is a little bit expensive. So if you have a building, an office building with 5 to 10 floors, maybe in every floor you have 1 or 2 HVAC units with its intake and outtake ducts. So you can imagine that there are a lot of square meters to test. So it is, if you have to test all the duct installed, it is going to be an expensive test. So this is the point for testing all the ducts or not, the cost of the test. Also, most of the times the installer doesn't know that they have to do the test, so they are installing the ducts, and then someone at the workplace tell him stop installing because we have to test. So it's a bad surprise for them because of the cost of the test, because they have to stop installing and they have to test, and obviously sometimes the test failed. We test with maybe 500 Pascal to 1000 Pascals, and not all the ducts are passing the test. You can see in this slide some equipment. The one at the left, I haven't used it, but I know it's a good equipment because you can test as many square meters as you can. There's no limit. It's really powerful. The second one is very comfortable because it's really weak. You can go with it. Just one person testing the ducts. It's really comfortable for the workplace. And the third one is really heavy, but also is more powerful. You can test really long duct test. So you have to choose what kind of unit are going to use in order to do the work the better you can. There are more, I think there are more manufacturers in the market. Also, my family company from years, my father had one like do-it-yourself unit with just the fan and the manometers, and he told me that long ago he has to test for some laboratories, and he do this unit. So you can see that since 20 or 25 years, this test was also mandatory. But there were really strange cases. Also, how is the leakages repartition? Well, obviously, when you have a duct, you have some leakage in the joints. Obviously, is the weakest point. Derivations, unions, they usually apply some kind of like a past in the joints. Also maybe in fiber ducts you have some points with a small break because of in work whatever can occur. And as you see in the anemometer in the center image, there is a small leakage because of a break in the duct. Dams and grills also they have some leakages. So when you are pressurizing and the test is failed, you have to look where is the duct, and it's not easy because, as I say, most of the times the test was not something that was how can I say, was like maybe the ceiling is also installed, or vertical ducts are not accessible. You can see where is the leakage, you can hear it. So maybe putting some smoke inside the machine, if you are pressurizing, you can see it's not easy, but maybe you can see where the fog is going out of the duct with the anemometer, but you can go through all the square meters with the anemometer looking for where is the leakage. So it's not easy to see where is the leakage, and if the test is not passing, probably you have to go again another day with the cost for the installer. So sometimes not all the square meters are being tested, and maybe they say, okay, we are going to test 1 or 2 floors and let's see how is going the installation. So as a conclusion, well, you can also in the finding of leakage, you can see at the left how we are taking the fog in the unit and looking through the duct where the fog is going out. Maybe sometimes you can use infrared thermal imaging, not always, because the metal is really reflective for infrared thermography. But as you can see, there are some thermal patterns that you can see as a leakage in the ducts. So I like to use all the methods: fog machine, thermal imaging, an anemometer, and even you can use obviously your hearings. You can hear where the air is flowing. So as a conclusion of this short presentation, I can say that not all the ducts are being tested, but yes, it is mandatory to test all ducts, all square meters installed in a building. Class A, B, C, or D. D are for some special application, maybe clean rooms or laboratories. But class B and C, you have to test all the square meters installed, and it's not always being tested because of the cost of this kind of test, and also because sometimes because people don't know they have to test the ducts, or the times in the work, you know, the ceiling are installed, the grills are installed sometimes, and then when they call me, I say we can't test because you have to seal off the grills, and there's more time to do this test. So you know, there's a lot of work to do still with this kind of test. So thank you for hearing, and if you have any question, pues I will answer if possible.